NAD+ has become one of the most discussed and most misunderstood molecules in longevity and regenerative medicine. Today, I'd like to take a step back from marketing narratives and return to first principles of biology. There is no dispute that NAD+ is fundamental to cellular health. It plays a central role in mitochondrial metabolism, DNA repair, redox balance, and cellular resilience, all processes that decline with age. However, acknowledging biological importance is not the same as validating every method proposed to restore it. A prevailing claim suggests that intravenous NAD+ directly replenishes intracellular or mitochondrial NAD pools, leading to rapid rejuvenation or mitochondrial reset. From a cell biology perspective, this interpretation is, at best, incomplete. NAD+ is a large, charged molecule. Most human cells do not import intact NAD+ efficiently.
Instead, intracellular NAD+ is maintained through tightly regulated salvage and synthesis pathways. Increasing circulating NAD does not reliably translate into increased intracellular or mitochondrial NAD, particularly across multiple membrane barriers.
Mitochondrial NAD+ pools are compartmentalized and stringently controlled. To date, there is no robust evidence demonstrating that intravenously administered NAD crosses the cellular and mitochondrial membranes in a way that meaningfully alters mitochondrial function. Claims of direct mitochondrial supercharging, therefore, exceed what current biology can support. While NAD levels decline with age, this decline is not primary. It is downstream. Chronic inflammation, DNA damage, increased PARP and CD38 activity, and mitochondrial dysfunction all accelerate NAD consumption. Without addressing these drivers, simply adding more substrate risks becoming a compensatory gesture rather than a regenerative intervention. Some individuals report transient improvements in energy, clarity, or mood following NAD+ infusions. These effects are real experiences, but they are not synonymous with cellular regeneration. Hydration, autonomic stimulation, expectancy effects, and relief of deficiency states can all contribute to short-term symptom improvement. Subjective benefit should not be confused with mechanistic reversal of aging biology.
The most consistent data supports strategies that enhance NAD where it is actually produced, inside the cell. Exercise, metabolic cycling, mitochondrial conditioning, and precursor-based approaches act upstream, influencing NAD+ flux rather than attempting passive replacement. In regenerative medicine, context and regulation matter more than concentration.
As Professor Dr. Patrick Treacy has long emphasized in regenerative medicine, aging is not a deficiency disease. It is a systems-level loss of biological coherence. True regeneration does not come from refilling a molecule, but from restoring signaling integrity, redox balance, and cellular adaptability. NAD+ is part of that system, but it is not the system itself. A balanced, evidence-aligned position is this: intravenous NAD may have short-term experiential effects in selected settings, but there is currently no strong evidence that it meaningfully restores intracellular or mitochondrial NAD or alters the aging trajectory. Long-term regenerative outcomes depend on endogenous synthesis, metabolic regulation, and mitochondrial competence, not passive infusion. In longevity medicine, our responsibility is not to chase intensity, novelty, or immediacy, but biological plausibility. NAD matters, but context matters more than concentration.